All right, AGS 1. Today we're going to talk about rational exponents, and this is 2.5. Before we get started, just a quick reminder that last video we learned about why x to the negative a is 1 over x to the a. Remember that if you have an example like 3 to the 4th equals 3 to the 9th, you can use the subtraction property, or there's two different ways you can do it. You could expand and say this is 4 3's on top, and then 9 3's on the bottom. Then you can cancel out, or not cancel out, make giant ones or whatever, 4 sets of 3's. So that's 1, 2, 3, 4. So those, notice that all of the 3's in the top went away. If everything ever goes away, you can just leave a giant 1 up there. So this is 3 times 3 times, oops, I missed one in there, so it's 5 of them left over, which is 1 over 3 to the 5th. So that is your answer for simplifying 3 to the 4th over 3 to the 9th. But if you take an alternate route and use the subtraction property, you get 3 to the 4 take away 9. Remember, because it's divided and it's the same base of 3, you subtract their exponents, and it's always top minus bottom. So 4 take away 9 is negative 5, so we get 3 to the negative 5th. Remember that by this property right here, if you ever wind up with a negative, to fully simplify your answer, you throw it in the denominator and make it positive, which is the same thing we got from the expansion method. Either way, our answers are 1 over 3 to the 5th. Now let's take a look at some radicals. So radicals are basically just like square roots or cube roots or fifth roots or fourth roots. Any type of root is a radical. So if it involves this sort of sign, it's a radical. So this first one here, the square root of 49. Remember that a square root, that you're trying to find a number that it's something times itself that gives you 49. So if I break this down into 7 times 7, that means the square root of 7 times 7 is just 7. One thing I want to note is that you can actually break these radicals apart when you have square root of 7 times 7, that this is square root of 7 times the square root of 7. So this is equal to 7. Another way to think of that is that it's square root of 7 times itself that gives you 7. So big part of today's lesson is that if you're squaring a square root, that the square and the square root go away. Now, I know you're looking at that and you're like, well, Jolly, come on, like square root of 49, you can just say, hey, it's 7 times 7, so the answer is just 7. You don't need to do split it up like that. Down the road, this is going to be useful that we can think of it like that, because today is all about these different exponent properties. Square root of 64 is square root of 8 times 8, which is just 8 on its own. Square root of 9 is square root of 3 times 3. So this is just 3. Another way I like to think of it is that square roots really like pairs of numbers. So if you have a pair inside the house, one of them can come to the outside and just be on the outside without the radical sign. Now, you guys, this last one, square root of 5. So you think to yourself, okay, what times itself gives us 5? If you try 3 times 3 is 9, 2 times 2 is 4. So it's it's in between 2 and 3. It's not really like an actual whole number, which is true. This is not a nice one. So I guess right now we can just leave it as the square root of 5. That's as simplified as it can get. You don't need to do the decimal on a calculator. You can just leave your answer as square root of 5. Now, let's take a look at this exponential table. So we have 2 to the x. Remember, if you put a 2 to the 0, that is 1. Now I'm going to jump to the next one, which is 2 to the 1, which is 2. Remember, anything to the 1 power is just itself. Then 2 squared is 4, and 2 cubed is 8. Now, a big part of today's lesson is talking about, well, what about if I zoom in right here? What if I go halfway in between? What is 2 to the 1/2? Now, if you use Desmos or a calculator or something like that and actually punch this in like 2 to the 1/2, you get 1.41 about. It's like a long decimal that's cut off. So the question is, like, where does this 1.41 come from? What is it? The way I think we should think about this is think of this whole like table as a geometric sequence or an exponential equation, but really it means that like to get from here to here, that the 1 gets multiplied by two things. So let's call it, and let's not call it R because R is like the big value, but let's call it like W or something, okay? That means that there was a times W that happened to take a 1 and turn it into a 2. So if we think 1 times W is equal to 2, that means W squared is equal to 2. Because W times W, remember you add their powers, that's W to the 1 times W to the 1, so that's W to the 2 power. But then to get rid of a square, to cancel out a square, you can do the opposite of squaring it and square root it. Which means that the number that got multiplied in between was the square root of 2. So if I remember like making these half step jumps, going, jumping from here to here and here to here and here to here and here to here and here to here, these are all times the square root of 2. So let's look at this a different way. We're still going to do 2 to the x, but now I've expanded the table, so it just always goes up by half steps. 0, half, 1, 3 halves, 2, 5 halves. So we already knew from the previous table that 2 to the 0 is 1, 2 to the 2 is, or 2 to the 1 is 2, 2 squared is 4. But now to go these little half steps in between, we're going to multiply times the square root of 2. So 1 times the square root of 2 is the square root of 2. Now this is a big moment for us, this right here, about what this actually means. This means that 2 to the 1/2 is the same thing as the square root of 2. This is one of the main points of today. Put stars around it. That means that we can move in between these forms, that 2 to the 1/2 is the same thing as the square root of 2. Then to get to this next spot here, you would take 2 and multiply it by the square root of 2. So this is 2 root 2. Then the next spot is 4. So this is times square root of 2. And then to get to the next spot again, it would be 4 root 2. Now, let's think to ourselves about whether or not, this 2 to the 1/2 equals square root of 2, if this makes sense in the larger scheme. So let's think well, there's a couple things to say about this. If you take square root of 2 and multiply it with itself, would this actually equal 2? So let's check to make sure that if you go square root of 2 times square root of 2 again, that you get 2. Remember that when you multiply something by itself, you're squaring it. So this is the square root of 2 squared. And then the square and the square root cancel each other out. So this is 2. So I guess I can go back up here and say the square root of 2 times the square root of 2 is 2. Now let's think about it in terms of our exponent properties. If you have the square root of 2 times the square root of 2 equaling 2, we know from this thing where we put stars around it that square root of 2 is the same thing as 2 to the 1/2 times 2 to the 1/2, and this equals 2 to the 1 power. Does this make sense? Yes. When you have the same base and you're multiplying, you can add their powers. So this becomes 2 to the 1/2 plus 1/2 is equal to 2 to the 1, and you get 2 to the 1 is equal to 2 to the 1. So it works using our exponent properties. Really, one of the main points I want to get at today is that, if you have the cubed root of 2, this is the same thing as 2 to the 1/3. So the square root of 2, we already realized, is 2 to the 1/2. And then if you have the fourth root of 2, this is 2 to the 1/4. I don't know if you guys are seeing the pattern, but this number that's in the cradle, as we call it, always goes into the denominator. And then you just put a 1 on the top. Now, how much more complicated can this get? Let's think. Gosh, if you have like 6 to the 2/3. Well, no, I don't necessarily want to do that example. Yeah, there's a lot of other roots that can get slightly more complicated. One way to think of it, one last example I want to do with you guys is if you have 2 to the 3/2. And then you might wonder, well, what does this equal? Remember that 2 to the 3/2 is the same thing as 2 to the 1/2 to the power of 3. So you can verify that a couple different ways, that it's 2 to the 1/2 times 2 to the 1/2 times 2 to the 1/2. And then if you were to add 1/2 plus 1/2 plus 1/2, you get 3/2. But we also know that 2 to the 1/2 is the same thing as a square root. So this is the square root of 2 cubed. Square root of 2 cubed, you can also write it this way. Square root of 2 to the 3rd. You can move that little 3 inside. That works as well. So the square root of 2 cubed is the same thing as 2 to the 3/2. Eventually, you guys should be able to move in between these fairly easily. Okay, you guys, good luck with your formative today. Hit me up if you have questions.